Talk about aggregate demand and how far it actually moves when there's a change or an external factor that moves aggregate demand curve either to the left or to the right. So how are we going to start this bad boy out? Let's start off this bad boy by taking a look at an economy where we have our C, our I, our G, and our XN. Each one of the components of our economy is spending $150 million. So if I add them all up, we're going to say total spending equals $600 million. But there's going to be a change. This is an image of our economy. I set the price level as price level equilibrium. Instead of using a deflator on the side, I said, hey, this is our starting price level. That way there's no discrepancies in here. And we say, okay, what are we looking at? We're looking at this initial aggregate demand curve, AD, just blank, just a simple AD curve. Now, with C, I, G, and XN all spending $150 million, we have a total GDP of $600 million in the economy. We're going to assume that consumer spending, for some reason, increases by $100. So there's going to be a change of spending that's going to move aggregate demand to the right. Now, logic says this spot is going to move from 600 to 700. When AD shifts to the right, increasing by $100, that should take us to 700. But in reality, we can't tell what's going to happen right now. We don't know what this value is. Today, our goal is to work with what we call spending multipliers and tax multipliers to determine how much change in actual GDP occurs when there's an initial change in spending. To do that, we're going to need what's called a simple spending multiplier. And to get the spending multiplier, we're going to have to go through a couple different steps to get there. But let's start off with the idea of what it is. The simple spending multiplier is what we use to find out how far aggregate demand is going to change based off of an initial change. An initial change in spending by either consumers, business, government, or net exports, as in people buying more products from us, becomes new income for consumers. Now, when you receive new income, there's two things you can do with it. You can go out and you can spend it, or you can save it. Now, these are pretty broad definitions. Saving it could be in the form of your savings account. It could be investing it some way into stocks or bonds, putting it in a fund, whatever, doesn't matter. You are keeping your wealth for the future, or you are utilizing it right now for your happiness. There's two things you can do with new money. So that in mind, why does San Diego like hosting the Comic-Con? Well, San Diego likes hosting Comic-Con, and any city likes hosting an event because an initial change in spending is going to set off what we call a spending change that gets magnified in the economy. Well, what the devil do I mean by that? Let's assume there's a change in spending in our economy, and a consumer who came to Comic-Con decides to spend $100 on Jason's product. He's got a little booth going on. Now, Jason can do two things with that money. He can spend it, or he could save it. Now, in this case, Jason's just going to spend all of it. So he's going to go off and spend $100 on Nancy's product. Now, Nancy has more income. So Nancy has two options. We just replace the name and say Nancy can spend it, or she can save it. Nancy decides, I'm going to spend all of it, and she goes off and buys $100 worth of Tiffany's product. So the result in this situation is a $300 increase in consumer spending. There was an initial spending of $100, and then it got multiplied by $200 in the economy. And we know this is a fictitious example because you're not always going to spend all your money, and not everybody's going to do the same thing, but essentially what we were looking at was something along this line. Let's just say our economy started off at $500. Now, there was an initial change of spending of $100 that would have pushed aggregate demand a little bit to the right. And that was $600. But then it got further multiplied in the economy, as that spending became other people's new income. So we'll add another $200 on that. Make sure I get all my zeros on there. And now we can see that that was a total change of $300 based off of an initial change of 100. So how does a simple spending multiplier work? The extent of the multiplier effect is directly related to the amount of new income that consumers spend versus save. You can have an economy where when you receive new income, you spend a large portion of it. If you spend a large portion of any new income, then your multiplier effect is going to be much larger, which means AD will go further to the right. I'm going to give it a whole bunch of arrows to indicate very far to the right. Whereas if you only spend a little bit of your new income, then the multiplier effect is going to be smaller, and you're going to have a smaller movement to the right. So here we're looking at AD going very far to the right, and over here we got AD moving just a little bit to the right. So to prove it, I came up with this activity, and I'm going to ask that you pause and actually work it out yourself. But let's read the directions, and then I'll show you what I did for the first round and how it makes sense. Or hopefully it makes sense. So directions. Assume there's an increase in spending in the economy of $100. The $100 increase in spending in the economy will increase the economy's GDP by 100 bucks. Then that spending will become income for consumers who will turn around and spend the money. Our goal is to calculate the total effect on the GDP after 3 rounds of spending based on the percentage of new income that consumers are willing to spend. And then end goal, we want to find out what's the relationship between the percentage of new income spent by consumers and the total change in GDP. So let's see what I did for round 1. So round 1, we've got an economy where anytime someone receives new income, they're going to spend 90% of it. So I receive $100 because that's our initial spending in the economy. $100 was spent. So I'm going to take 100 times 0.9. That means the first consumer took that initial spending of $100, he saved $10 of it, and went out and spent 90 bucks. Now this guy received 90 bucks, and he said, all right, well, I'm going to spend 90% of it. So 90% of 90 is 81, and he spent that here. This dude said, oh cool, I received $81. I'm going to spend 90% of it. So he went out and spent $72.90. What's the total change in GDP, including the initial? I'd say the initial spending was $100. And then the remaining, I had 90 plus 81 plus 72. So 343. My total change in the GDP based off of this $100 initial spending increased my GDP by $343.90. Got my 239 that I calculated here by adding these up, and I added it to that initial spending because that counts. So I'm going to ask that you pause it there, and let's tackle this bad boy, and we'll see what happens. All right, hopefully you've solved it, unpaused it. So what am I looking at? Well, 75% of 100 is 75 bucks. 75% of 75 is $56.25. 75% of this is $42.19. So what do I have? I have $100 of my initial spending plus $173.44. So my total came out to be $273.44. I'll put it right here so we're following the pattern and it looks nice. Make sure I got my dollar signs everywhere. And we're good. All right, spending is going to drop even more. This time we're looking at 50%. 50% of $100, 50. 50% of 50, 25. And 50% of 25 is 12.5. All right, so add those puppies up. My initial spending counts towards GDP, plus 50 plus 25 plus $12.50. I'm looking at $87.50, or a total change in GDP of $187.50. And we'll put that right there. So you can see it in two spots. And finally, an economy where they spend really little. They received an initial change of spending of $100. They're going to spend $25 of it. 25 is spent. 25% of $25 is $6.25, or $6.25. And 25% of that is $1.56. That first round of spending is going to count at $100, plus all these bad boys added up, which was $32.81. So our total change in GDP is going to be $132.81. So what can I see? What's the relationship between the percentage of new income and the total change in GDP? The higher the percentage change in new income will result in the larger or greater changes in GDP. Sound good? So to determine a spending multiplier, we got to figure out how the economy spends and saves. Because it's safe to say we know that if an economy spends a lot more of its new income, it'll have a greater effect on GDP, and if an economy spends a little bit of their new income, it'll have a smaller effect on GDP. So we need to find a way to measure that. We're going to use what we call the marginal propensity to consume to record this information, and later to help us find the spending multiplier. What's the marginal propensity to consume? It's how much people consume, that means spend, rather than save when there's a change in disposable income. We're going to express it as a decimal unless it's a solid number. And we're given this equation right here. MPC, or your marginal propensity to consume, is your change in consumption over your change in disposable income. So down here I got an example. You received $100. That's my change in disposable income. I spent 50 of it. That's my change in consumption. So my MPC is 0.5. Let's pause it and see if you can tackle these bad boys. Okay, hopefully you've unpaused. If you received $100 and you spent 80 of it, my change in disposable income is $100. If I spent 80 of it, that's my change in consumption. I'd say my MPC is 0.8. If you received $100 and you spent $100, you're not very responsible, but you're a party. Your MPC is 1. If I got a marginal propensity to consume, I have the flip side too. I'm going to have myself a marginal propensity to save. It's the exact same thing, but savings instead of consumption. It's how much people save rather than consume when there's a change in disposable income. Again, expressed as a decimal, and my MPS is a change in savings divided by the change in disposable income. So my first example, this time I have a change in disposable income of $100. I received $100. I saved 50 of it. So my MPS in this case, 0.5. All right, let's ponder this bad boy. If you received $100, there's my change in disposable income, and my MPC is 0.7, then what's my MPS? Oh my gosh, this is some complicated stuff here. I received $100. They're telling me that my MPC 0.7. That means I spent 70 bucks, which means I saved 30 bucks. Aha, all right. So in this case, my NPS is 0.3. Cool, moving along. That last problem gave us this idea. Your MPS and your MPC have to equal 1. Why is this true? Because people can do two things. If you receive money, like in our last example, you receive $100, you can spend it or you can save it. And those values always have to add up to 100. Complicated math time. Now that I claimed it, I hope I don't mess it up. But if my MPC is 0.75, I received 100 bucks, I spent 75 of it, that means I had to save the remainder, $25. If I received $100, my MPS is 0.5, means I spent the other 0.5. 0.3, 0.7, 0.75, 0.1, 6. This is kind of fun. Have I messed one up yet? Don't know. Something like that. They always have to add up to 1 because you can either spend it or you can save it. They might give you the information in different ways. So here's two other ways that we might look at it when we get a question about MPC, MPS. So over here, I've got a change in income. Over here, I got my change in consumption. So how do I get to my information? Well, let's do change in consumption first. So I'm going to say, all right, in year 2, my consumption was $57,500. In year 1, my consumption was $50,000. All right, so what was my change in consumption between these 2 years? $7,500. I also have my income over here. Now on this side I say, all right, my second year, my income was $110,000. And in my first year, my income was $100,000. So what's my change in income? It was $10,000. So in this case, what's my MPC? My MPC would be 0.75. That's how you might get it if it comes in a stimulus where you just have 2 years, but you might also get a table. In this table, you're going to get a series of years. I got a starting point of 2020. I know what my income is. I know what my expenditures are, but I have no idea what 2019 is. So since I don't have these values, I can't figure out my MPC, MPS. But since I do have 2021 and 2022, I can say, ooh, look at that. Here, I can solve some information. My income is here, and my expenditure is here. So disposable income and consumption. So, what happened with my consumption? I spent $80,000 this year. I spent $90,000 this year. So my change in consumption was $10,000. What was happening with my income? I made $100,000 this year, and I made $120,000 this year. So my change in income was $20,000. 10,000 divided by 20,000 is 0.5. If my MPC is 0.5, my MPS is 0.5, because they have to add up to 1. So what about this one? Actually, you know what? Pause it. So let's give a little pause action and then come back and let's try it out. All right, hopefully you've unpaused. So I'm going to do the next one. In 2021, I spent $90,000. In 2022, I spent $99,000. So my change in consumption is $9,000. I'm going to divide that by my change in income. My change in income is right here. 2021, I made $120,000. 2022, I made $130,000. Okay, so my change in income was $10,000. So My MPC is 0.9, making my MPS 0.1. And for our last year, we can see the change in my expenditures. I went up to 106,500, and I was spending 99,000. Subtract, I'm looking at a change in consumption of 7,500 divided by a change in income over here of 30,000. So in this case, whoa, there it is. It was 0.25 for my MPC, making my MPS 0.75. Notice the income's changing and consumption's changing. That's how you work this problem. On the day of the test, it will definitely be one of these bad boys. All right, mental break, pause it, do whatever it is you're doing. But I'm in a rush, so I'm going to keep going. So why did we do this? Why did we figure out change in consumption, change in savings, MPC, MPS? Because we're going back to this idea right here. If I can track it way back. Yeah, that's right. I'm doing this on paper. Well, there it is. The idea that if you spend a large portion of your new income, you're going to have a big AD shift. If you spend a small portion of your income, you're going to have a small AD shift. So we can now use our MPC, MPSs to get our multiplier. So how do we calculate a spending multiplier? The spending multiplier is simply 1 divided by our MPS. So that's why we had to figure out the relationship between MPC and MPS. Because if you have an MPC of 0.5, what's going to be your multiplier? Like, oh, what's my MPS? Well, if my MPC is 0.75, then my MPS is 0.5. 1 divided by 0.5 is going to be your spending multiplier. So in this case, my answer is 2. Let's pause it and try to do these two right here. Okay, unpausing. For this question right here, I'm going to say my MPC is 0.75. So if my MPC is 0.75, then my MPS must be 0.25. So my spending multiplier is 1 divided by 0.25. My spending multiplier is 4. How about this one right here? This is nice because I don't have to divide it up. So I'm going to say my spending multiplier is 1 over MPS. They straight up gave me the MPS, so my multiplier is 5. Cool, spending multiplier. So now we can take a look at this one, and I just printed this off the PowerPoint, so we're just going to have to roll with it. We're going to say, assume the MPC for everybody in the economy is 0.75. And that's our assumption with all problems, that our economy is operating at one specific MPC. But that's not the case in real life. Everybody has their own MPC, MPS. Assume Comic-Con comes to town and there's an increase in $100 in Ashley's restaurant. All right, so our initial change of spending is $100. Now Ashley has $100 of more income, and she can either spend it or save it. Since our MPC is 0.75, she's going to save 50, and she's going to spend 50. And she spent that 50 at Carl's Saloon. Carl's got 50% more income, so what is he going to do? He can either spend it or save it. So he's going to save half of it and spend half of it. He saves 25 bucks and he spends $25 at Dan's fruit stand. Now Dan has $25 more of income, and this is going to continue on and on and on and on until every penny is spent or saved. Instead of doing that, we can just use our multiplier. If my MPC is 0.75, then my spending multiplier is 1 divided by 0.5, or my multiplier is 2. Now I can say 2 times my initial spending will give me my total change in GDP of $200. So, in that case, we started off on this curve right here at AD and a price level. I arbitrarily chose 600 bucks, and we said that there is a change in spending of $100. Now, if there's a change of spending of $100, it'll move slightly over for that 100, but then as this money becomes people's income and then future spending, we get a push to the right for a total change of $200. How far it goes is our total change. Our initial change is the first spending that occurred right here at Ashley's restaurant. So I got a couple practice problems for you. We're going to be using this equation right here, total change in GDP equals a multiplier times our initial change. You got your spending multiplier right here, so you're all set. Why don't we pause it, and we'll go from there. All right, hopefully you're unpaused. I am running out of time, so I'm going to pick this bad boy up. Let's go with my MPC is 0.5, so my MPS is 0.5. Hopefully this color is working. I think red might have been a bad choice. I bet you I can use my Sharpie. Yeah, all right. Now I got a runaway pen. So if my MPC is 0.5, my MPS is 0.5. So my spending multiplier is 2. So in this case, my total change in GDP based off of an initial change of $200, I'd say 2 million times 2 equals a total change in GDP of $4 million. For the next one, if my MPC is 0.75, MPC is 0.75, that means my MPS is 0.25. So my spending multiplier will be 1 divided by 0.25, or 4. So what's the change? If there's a change of spending of 5 million times a multiplier of 4, my total change in GDP will be 20 million. Initial change times the multiplier is our total change. And our last, nope, not last one. If the MPS is 0.2, thank you, that makes it a lot easier. My MPS equals 1 divided by 0.2, so my multiplier is 5. In this case, there's a decrease of spending, so we're working negative this time. So we got a decrease of 3 million times a multiplier of 5. My total change in GDP will be negative 15 million. AD would be going to the left this time. And here comes our trick question. If the MPC is 0, that means my MPS is 1. So 1 divided by 1 is 1. If investment spending increases by 2 million, 2 million times the multiplier of 1 equals a total change of 2 million. That's boring. All right, so let's get a couple problems here. I'm going to say pause it, think it, and then unpause it. All right, unpause. A high marginal propensity to consume implies which of the following? Let's see, small change in consumption. Well, if you have a high marginal propensity to consume, then you have a low marginal propensity to save. If this is 0.9, that is 0.9, this needs to be 0.1. Which of the following is true about the marginal propensity to consume? Pause, come back. All right, this one really frustrates everybody every year, but if you know your MPC, then you can figure out your MPS, use your MPS to figure out your spending multiplier. So in this case, it determines the size of the spending multiplier. The higher your MPC, the lower your MPS, bigger the multiplier. None of these can be proved, so we'll just drop them out. Like, it is the percentage of total income that's spent on consumption. No, it's the change in consumption. C, it increases as income increases because increases in income cause people to spend more. Not necessarily. What if you make more money and now you realize, ooh, I could save up for something that I really want, and your MPS actually goes up. It's the same as the money multiplier. What's the money multiplier? We won't get that until unit 4. And it's equal to the average. We don't do that. So that's out. Our next one is number 48. In a closed economy with only lump sum taxation, if the marginal propensity to consume is equal to 0.75, a $70 billion increase in government spending will cause a maximum increase in output of. Wow! All right, pause it. Yeah, I'm gonna check my answer. Yeah, there we go. Suppose an economy with lump sum taxes and no international trade, autonomous investment spending increases by 2 million if the MPC is 0.75. Equilibrium gross domestic product will change by a maximum of. A lot of stuff that doesn't pertain to us at all. All we need to hear is spending by 2 million with 0.75. So spending multiplier is 1 divided by MPS, which is 0.25, so we got 4. So our total change in GDP equals my multiplier times my initial change. My initial change here is going to be 2 million. My multiplier is going to be 4. So we're looking at 8 million. All right, I got to pause real quick. Let's see if this works. Okay, unpause. So let's see if this actually works out. We have one more to go. Oh, no we don't. All right, that was my answer key. So let's drop that, drop that, drop that. Why? Because a tax multiplier will also affect the way. Multiplier effect also applies when government changes taxes or transfer payments. So what does that mean? It means if there's a decrease in taxes, consumers will have more disposable income and they will spend part of it. So when we were looking at our aggregate demand curve with price level and GDP right here, one of our shifters of aggregate demand for consumers was taxes. If the government decides that they're going to decrease taxes, then I'm going to have more disposable income, and my aggregate demand is going to shift to the right as I go and spend more money. If the government cuts my taxes, it's safe to say I'm going to spend some more money. And the same thing is if a person receives a transfer payment. They'll have more disposable income, and they're going to go out and they're going to spend part of it. So that's a strange one, because we've talked about transfer payments don't count towards GDP. If $100 is sent from Mr. Wade to Mr. Owen, that doesn't count in GDP. That's just money going back and forth. But if I received $100 from Mr. Wade, well, I might save some of it. Let's say I save 25 bucks, and then I'll go out there and spend $75. This initial didn't count. The spending did count, because that purchased a good or service. So let's see how this works out. So taxes and transfers work differently because the initial change doesn't count towards GDP. I'm going to pause real quick. Okay, let's see how these bad boys work differently. So taxes and transfers work differently because the initial change doesn't count towards GDP. So we just did the example a second ago with Mr. Wade giving me money. The same thing happens with a tax cut. So when we talked about shifters of aggregate demand, tax cuts don't count. So if you see a tax cut of $100 million, that doesn't count towards GDP. That just means I have more money. Now, I can't count it towards GDP, so I have to say, what's my MPC, MPS? The first round of spending occurs after I saved part of it. So if I receive a tax cut of $100, I'm going to save $25, and then I'm going to go out and spend $75. So then I can start working this out. I can say, all right, if my spending is, you know what, let's just write the equation out. Let's go with total change in GDP equals my multiplier times my initial change. So with an MPS of 0.25, I can use my spending multiplier approach and say, all right, 1 divided by 0.25 is 4. So my multiplier is 4. My initial spending is 75. Yep, I'm going to multiply that on a calculator just so I don't make a mistake. I think it's 300. It is 300. So I'd say my total change in GDP is 300. The same thing would happen with an unemployment check. If I received an unemployment check of $100, nothing is being made. This is a non-production transaction. It's a transfer payment. So it doesn't count towards GDP. But the same thing would apply. I figure out how much I save. I save 25 bucks. I'm going to spend 75 bucks. So I'm using the same thing here. Tax cuts and transfer payments work differently because the initial change doesn't count towards GDP. We have to start it after that first round. Now this is kind of tedious if you ask me, and there's more ways to make a mistake because I'm seeing a number, I'm working out the MPS, working out the MPC, then plugging it in my equation. So we're fortunate that we have a transfer and tax multiplier that makes it easier for us. Less things to move around and less things to mess up. So if my MPC is 0.75, what's my tax multiplier? Well, I come down here and say, all right, so what's my simple tax/transfer multiplier? I just abbreviate this as TM, kind of like I do my spending multiplier as SM. Well, I know my MPC is 0.75. If my MPC is 0.75, my MPS is 0.25. So in this case, my tax multiplier is going to be 3. And then I would just use the same equation. My total change in GDP is going to be my tax or transfer multiplier times my initial change in taxes. So if I wanted to use something like this, where I said, hey, I got a tax cut of $100, I can just say, hey, my initial change in taxes was $100. My multiplier is 3. My total change in GDP is 300. Let's scope back and see if that's the same value. Oh yeah, look at that. Way less work. We took 100, we broke it into savings and spending, then we took spending, added it over here, then we figured out a spending multiplier. 75 times 4 equals 300. That is so many spots where Mr. O can make a mistake. Why not just use this bad boy right here? The other cool trick code is my spending multiplier was 4. My tax multiplier is 3. Spending multiplier is 4. Tax multiplier is 3. 4, 3, 4, 3. The tax multiplier will always be 1 less than the spending multiplier. It always works out that way. Perfect cheat code. Okay, so with this one, we have answer the following questions assuming the MPC is 0.8. So I'm going to pause right here and let you work it out. Okay, so number 1, now I'm going to look at my MPC is 0.8, so my MPS is 0.2. That'll allow me to solve for my tax transfer multiplier, which is 4. What is the total change in spending as a result of a $50 million tax cut? All right, well, the tax cut doesn't count towards GDP, so I'm going to use the tax or transfer multiplier because they're saying tax cut. So let's take a look. I'm going to take my initial change in spending is 50 million times my multiplier, which is 4. So my total change in GDP is 200. Number 2, what is the total change in spending as a result of $300 million increase in transfer payments? Okay, I got 30 million. That's my initial change. My multiplier is the same because we're operating on all of them with a 0.8 and a 0.2. So 30 times 4. I know it's 120, but I never trust myself. Boom. Here's the one thing we got to remember. A tax cut, AD goes to the right. If it's an increase in taxes, AD goes to the left. Tax cut, you get more disposable income, you're going to spend more money going to the right. If there's a tax increase, you have less disposable income, you're going to spend less money. So don't let that freak you out. That's the flipped version. And then the last one, whoops, I guess I used my answer key version on that one, but let's talk it out. If the government increases spending on goods and services and increases taxation by the same amount, which of the following will occur? Ooh, all right, so if you're increasing spending, AD goes to the right. If you increase taxation, AD goes to the left. So these are working in opposite directions, right? But why would it be this answer right here? Why would aggregate demand increase? Well, it's because the spending multiplier is greater than the tax multiplier. So let's do that last one again. We had an MPC of 0.8 and an MPS of 0.2. So my spending multiplier is going to be 1 divided by MPS. My tax multiplier is MPC divided by MPS. So 1 divided by 0.2 is 5. And 0.8 divided by 0.2 is 4. So if I was going to increase spending by $5 million with a spending multiplier of 5, AD would go to the right by 25 million. If I increase taxes by the same amount, by 25, and I apply my tax multiplier, AD is going to go to the left this time by 20 million. So the net difference would be 5. AD would be going to the right by $5 million because the spending multiplier is greater than the tax multiplier. All right, we did it. We did a lecture on paper. Thanks for watching.